Hello everyone. So welcome to my channel. Today we are going to do Leetcode daily challenge, substring with concatenation of all words. Before doing this question, let us go through the question that what exactly it want to say and about the constraints which are there so that we could better understand the question. So now, as per the question says that you are given a string S and an array of strings words of the same length. So here this point required to be noticed, means all the bold ones are required to be noticed. So we are given with this string S and we are given with string an array of strings whose name is words and all are of same length. Now return all starting indices of substrings in S. So here we are required to check for the substrings which are there, that is concatenation of each word, and that substring simply would be a substring in this particular string, but that substring should have the value of concatenation of each word in words, means concatenation of these words, and how that concatenation is required to be performed by exactly one in any order. That is, we don't require any duplication, and these words should be in such a manner that if who comes first, then it is not necessary that who always comes first. We can also write like this also, or we can write like this also. So that's what they want to say, that it can be in any order and without any intervening character. So here in between, any other character shouldn't be there. So these are the few points which we are required to keep in mind while doing this question. And at the end, you can return the answer in any order. That is the indices which we'll get, that is the 0, 9 and 9, 0. Both of them answers are the perfect ones. So this is what they want from us. So now comes the part that you can see that what we are required. That first thing is that there should be a substring, and that substring is basically concatenation of all words. Means if any one of the word is skipped, then that won't be a valid substring. And the other point about the substring is no duplication allowed. And the third point of this substring is that any order can be there. So these are the things we are required to check. Here no duplication simply means that if this particular foo comes only one time in this word, then only one occurrence should be there in the substring. But in the second example, we can say that word comes 2 times. So even if the word itself comes 2 times in this word, so you can use this as it is. Means if there would have been a string like word good and then best, if this would have, if we say this word best good and one more is missing, right? That is if this would have been word, right? So then it would have been a valid substring. But as nothing is here the way it should be, so that's why here we are required to return null. That is no indices should be there. Okay, yeah. So now comes the part, this was about the substring. Now comes the part about one more thing was there. Substring is done. Okay, right. So we are required to get a substring, right? And in the substring also, now comes the part that we need to store the indices. That is the starting indices of the occurrence of the substrings in this string, in the input string which is given to us. So how we can do this? So just if we think about the same, means it is some sort of sliding window, right? That this bar foo is coming, then foo bar is coming, and how we are required to check for the window size. Here comes the part of this particular keyword which is given to us, that it is of the same length. So that is the thing. So gives us that as it is of the same length, and then comes the part that what is the length of the words which is given to us. So our window's size would be directly equal to the size of one word into the length of this particular array. So that would give us the size of our window. So that is the thing which we will be doing. Now besides this window, we also required to check for the duplication part, and also need to check that are all the words being concatenated or not. So for all this scenario, we will maintain a hash map. So for that part, we will be easily able to come up that are there any duplicates or are there concatenation of all words. So that's the thing required to be handled by hash map. So this is the overview of question, that how this question is required to be done. It is a sliding window question because we need to slide over this string to get our substring, and that substring is also we are required to get from these particular rules. So this was the thing. Now comes the part that how we are required to code this particular question. Let me get a screenshot of the same because I want to clear this board. So then it would be easy for us to keep in mind that what all things we need to get into our mind. Because I'm not using both for time being. So let us now see that how we are required to code this particular question. Although I've already commented out the things which are required, but still. So these were the conditions which we were considering. Now here comes the coding part. So how we are coding is that first thing. So the first thing is about the unordered map. So this unordered map is basically for this fact so that we could store all the words which are there in our words vector of string, so that we can easily check that are all the words being concatenated and what is if there is duplication or not. So for that factor only we are doing this particular steps. Now comes the next part, that where we are required to store the indices. Basically the answer is being stored into this, and then we are checking for the length of our input string, then number of words which are there, and what is the length of each word. So this is what we are doing in this particular step. Now comes the part that how we are required to perform a sliding window. So we will be starting from the start of our input string, and in that we will go until this particular length. Why we are doing so? Because else we would be encountering a runtime error, because it will go out of bounds, because we will be performing checking for the substring, and because of this fact only we are obliged to take until this length. So how we are taking is the length of the input string subtracted by number of times the words are there in our words vector of string into the length of each word plus 1, and then we will check for our unordered map, and in this unordered map we are simply storing the occurrence of each word which we encountered in our input string. So now comes the part we will be starting from 0 and then checking till the number of words which are being stored in the word vector of string, and the first thing we'll do is we'll get the word substring of that particular word in this particular word variable. And how we are getting that? We are just checking from the I index means from that particular character itself, because no other character should be in between the concatenation of the words. That's why we need to keep that check also. So we are starting from here plus we are going till the length into the starting of this particular j, and then we are directly going till the length of that particular word, because we need a substring of concatenation of all. So that's why. So here the concatenation part won't be able to be checked, but the thing which will be checked here is that does that particular word really exist in a string or not. Now here we are checking that if that particular word already exists, means this is not a word which is not expected. If that is unexpected word, then we'll go to this condition and we'll directly break. But if it is expected word, then we'll go to this condition. We'll update the occurrence in the scene unordered map, and then we'll check that if scene of word is greater than counts of word, that simply means that there is some duplication. So at that point only we'll break, else the thing would be we'll move ahead in this particular loop. Now comes the part that after we come out of this particular loop, right, then we'll check that if array equals to num, so then at that particular point only, this simply indicates that all the words have been checked. So there is a complete concatenation, and that's why we now reached at this particular position, and thus we will push the index I at this particular moment of time, because I is that index which is the starting of the concatenation of all these words. Basically, the starting of the substring which has the concatenation of all these words. So that's why we are doing this particular step. And then we'll again run this particular loop for the next character, and again this whole process will move forward, and then we will be able to count up all the occurrences of the concatenated words which are there in our words vector of string. So at the end we will directly return this indices, and this is how we are required to solve this question. So now comes the part that what is time complexity and space complexity. So time complexity for this particular question is order of size of the input string and multiply by words dot size. Why it's so? Because you can see in the inner loop we are going till the size of the words, and in the outer loop we are almost going the length of the whole string. As per the constraints which are being given to us, you can see the length of the string is 10 raised to power 4 and the word length is 5000, and 5000 is somehow negligible in terms of 10 raised to power 4, right? So that's why when we are subtracting this particular, right, from the length, and even if we say that words are not as 30 and if there are just 2 words, means the subtraction part which is being done from the length of the 10 raised to power 4, that would be also negligible in that sense, right? So that's why here the thing would be that this whole particular would be of the length of this particular input string. So that's why this whole algorithm is basically s.size into words.size time complexity. And now comes the part for the space complexity, that is words.size. Now why words.size? Because we are using one unordered map for storing all the words here, right? And then we are again using one unordered map for storing the occurrences of these words, which can at max go till the length of this particular only, because duplications are not allowed, and when some duplication comes up, then at that moment only it breaks. So that's why this filling is not done again. So that's why that space complexity for the same is words.size. So this was all for this particular question. If you have any doubt, please do comment it down, and thank you.